I don't know if I'm the only
On the
aerospace
Fifth
student.
Avenue. No, there are five of you, but the other ones for some reason hide. I don't know where they are.
I mean, are they still enrolled?
Yeah, I think I'll send you the list for his visit.
Um,
What was the last homework they submitted?
What do you say?
What was the last homework assignment they submitted?
Everybody's submitting homeworks.
Oh,
Everybody.
okay.
well, I was just going to say, from my perspective, as perhaps the last or something, the whole homework seemed like nonsense from beginning to end. And the first two times I tried to do it, I
You mean
closed
the
it.
complex one?
Yeah, because I managed to get a degree in aerospace engineering and never even saw anything that even remotely looked like that, let alone holomorphic mapping. And so it was a real struggle to
Hmm.
understand. And I feel like
Yeah, yeah.
I broke through yesterday, but it was a little bit too late. But it was a real
Interesting.
struggle. But I think what got me there was I'm familiar with digital image processing, and it
Yeah,
reminded me of rigid transformation versus the affine transformation,
yeah,
if you know what
yeah.
that is.
No, that's yeah, sure, very relevant. Yeah,
And that's just
right.
optical flow
Yeah.
that I use for my research.
So not rocket science, but optics that help you. Because in optics, it's totally essential, right? Because what will happen next? But I can't imagine how you do rockets without Fourier analysis. I will, apply this to Fourier analysis. That's very tangible thing, but it's application of complex analysis because Fourier modes are in complex space. I mean, that's the whole idea. But it's one way to go to many dimensions using complex analysis. Because you can Fourier mode, Fourier expand every direction separately.
Yeah,
Now,
I think the equations we need are gift wrapped, and what they mean are explained to engineers so that we can avoid having to truly learn about them.
yeah, but the world is constantly changing. So it's true that we train some engineers to build bridges or culverts of the specific kind, and they do it generation after generation. But even bridges change, and when you come to aeronautics, things change from decade to decade in very radical ways. For example, President Putin and his assets in the United States have hypersonic rockets, vehicles, which could kill more people. So, they're all designed by Fourier analysis. They have to, all the computations are done in waves, in media, in friction, in hyperbolic things, and things that are exponential growth. So I can imagine how real design in engineering of new things, things you haven't built before, would go without knowing complex analysis. I'm almost sure you need to know it.
Me
And
too.
you need to know it if you're doing image recognition, because in image recognition, one of the problems is you go from digital to analog back and forth because today an image is pixelated. It's a bunch of points with discretized values, which are called colors at each point. And you know that you can have two pictures of Alaric, which is the same person, but if you compare the pixelated images, it's miles away as a humming distance because all pixels are different. So what do? We smooth it out. How do we smooth it out? We take the image, we take its Fourier transform in every direction. Fourier transform captures the small variations first, long wavelengths, and then finer, finer. Then we truncate that in Fourier space because, very high frequencies in Fourier space corresponds to changing the value of pixel from pixel, not averages or regions of pixels. So, high frequency has to be filtered out. We go through filter, we'll cut this out. Then we Fourier transfer back. We get an image that to human eye looks exactly the same because, we cannot distinguish individual pixels and their variations. But it's a very compact image for image recognition because it uses a small number of Fourier modes rather than, megapixels or terapixels of original image. And that's done by Fourier analysis. It's a important feature of the systems are smooth variations. And after, certain wavelength, human eye, or there's no information that should be included in recognition, pattern recognition problem. That was invented by Fourier for totally different purpose, to make heat engines, because they're worrying about engineering problems, the steam engines, how to make them good, better, can they produce infinite energy, stuff like that. So he invented Fourier analysis to solve problem of heat diffusion, which looks very different. And that's an example of, what research is. You invent something for some reason that nobody understands why the hell you're doing it. Then for 2 centuries afterwards, it's totally crucial in everything. Fourier had no idea that, his method of solving a problem that has Gaussians in it and some variations around them would be the main engine of progress and civilization for all times to come. So I don't feel guilty, but I'm a little bit, worried about the engineering education. Anyway, sorry, but, just talk to me because lots of problems are just semantic, just like amphitwist. You actually have the idea, but I'm giving you some language like holomorphic. Today I'll say meromorphic. It's some stupid words that I have to say because in the literature, that's what specialists use. It's a jargon of the literatures. So when you encounter them, you'll say, holomorphic just means it's differentiable. I can take a derivative. But they call it holomorphic. Now, they have very good reason because they have to distinguish holomorphic from meromorphic. Now, what's a meromorphic? Meromorphic is differentiable almost every place except at points which are called poles, where you have singularities. So, it's a word that I want to define once and then they use it for a whole semester. But for you, it just gets into your way, because
No.
who needs this word, right? But you need it because you need to be able to understand what other people are saying, the specialists in the subject. So now, are there other questions? Thanks a lot. I think these questions are very useful. They're as useful to me as to you because for me it's hard to understand where the problems to understanding lie when one gives a familiar subject, to me familiar subject.